Hello, everybody. Welcome back. This is our Eloquent JavaScript book club meeting. We are reading a chapter a week of Eloquent JavaScript. Hi, my name is Angela, and I am joined this week by the lovely Charmel and Nayana. And we're going to talk about chapter 3, functions, all of the fun things in functions. So, functions are a really big part of JavaScript. Everything is a function. They're the things, they're the movers, they're the shakers. So this week we are going to go over functions, and I'm going to let Charmel take it away.
Thank you. So yes, we are talking about functions. So I'm going to share what I have here. Just made a little thing here. As Angela said, functions are essentially the building blocks of coding. Specifically when we're talking about it in the instance of JavaScript, it's the fundamental building blocks to get your code to do a thing. A function is a code snippet that can be called by other code, or it can be called by itself, or it can be defined as a variable, and then you can call that thing, you can call that function to do something. You can name a function or leave it anonymous. It doesn't really matter. It's helpful to name it so that you can separate what it's supposed to do and know, what it is doing. Additionally, when a function is called, you can pass into it some arguments to sort of activate its internal workings so that you can get an output or a return. So these are the parts of a function. So as noted before, this right here is a variable, but we don't use the term variable anymore in ES6. So it's let, and then this is defining the function right here. It's being named as my function. The arguments section is the information that you're passing into the function to get it to do something. When we're talking about scope, there are two forms of scope. There's global scope, which is you can define a variable outside of your function and it can be pulled inside of the function and used. Or you can define something within your code block right here, which would be a part of the local scope and can only be used within that function. And then down below, as a new part of ES6, you can use a less verbose version of identifying a function. And basically, it has the same parts as the traditional way. So constant is the same, it's very similar to let, it's not exactly the same, but it doesn't necessarily change, whereas let you can sort of reassign something to a let. My function, it has a name, same as up here. You also pass it arguments to do something in the middle. With setting up functions, what you can do is sort of, and this was alluded to in the first slide, you can call a function within a function, and you can call that function on itself. When you call that same function within itself, that is called recursion. It's very similar to the movie Inception, where you're dreaming inside of a dream. That's essentially what Inception is about. Inception is a giant movie about recursion. You can use recursion to sort of reduce down a problem. So let's say that you're trying to find the prime numbers for 100. Well, you would first say, divide 100 in half, so you get 2 and 50. Well, 2 can't break down any further. 2 is a prime number, but now you have to break down 50. And your constant going through that is your own recursion of trying to get to a smaller number for the prime number. So, as I noted, the parts of recursion are your overall sort of large function, which in this case is called my function, and you can pass that argument. And then inside of my function, you have something else called inner function, which is doing something, and you call for the value of inner function. which also can be passed arguments. It acts just like a normal function. And that would be the start of your recursion. So that would be where we get our, 2 and 50 broken out. And that's where we would pass 50 again to go all the way back through to get, a smaller number. We might get 5 and 10 at that point. And then we would keep going until 10 gets broken down to 2 and 5. And then we would see our prime numbers are 2 and 5 that make up 100, if we were to go through that as our recursion problem. One of the things that you have to be careful with when you're working with recursion is ensuring that you don't create an infinite loop, which will inherently crash your browser, or sort of call recursion too many times, because basically the stack, or how each of these functions is sort of called upon and they sort of layer into each other, if the stack gets too large, it will also crash, and you will get a notice about that in your console. So here's my example of recursion. The outer function in this case is called isEven, and the point of this function is to find out whether or not a number is actually even. So can you guys see my screen?
Perfectly.
Okay, great. So with that, you would pass it an even number. In this case, I'm passing it 50. And with passing it 50, this first line that I have here that says let test equal math.floor, and then it's number divided by 1 and then 10%. Essentially what I did was kind of game the system, right? I used old school 3rd grade math rules, and basically you don't need to know the whole number to know if a number is even or odd. You just need to know what's in the ones place. And based on old school math rules, that's what I used. So I am telling this math.floor to just isolate the number in the ones place. So whatever number I pass you, you just tell me what that number is. And that's what test turns out to be. Test will be whatever that ones digit is. I am then going into my inner function and passing test as the argument. And I am saying if test is greater than or equal than 2, then I want you to tell me that it's greater than or equal than 2. Greater than or equal to 2. And then I also want you to subtract 2 for me, because I want to get it as small as possible to see if it can continue to be reduced down, because I want it at its smallest point to absolutely see if it is divisible by 2, thereby saying, yes, it is actually an even number. But as you can see, in order to do that, I'm returning inner. I'm returning this function. So this is one step of the recursion right here. Now, I have different parameters also to test depending on what number gets passed in. So like if I were to pass in 7, it would go through this section several times until it gets down to a number that is, it would keep going through that until it turns out a number that's either equal to 1, equal to 0, divisible by 2, or less than 0. And it would tell me, if it's equal to 1, then it's going to tell me that it's false, meaning that it's an odd number. If it ends in 0, which in this case 50 does, it's going to tell me true, because that's telling me it is an even number. If it is divisible by 2, like if this number was 52, it would hit here, and it would pass true again, because again, it's divisible by 2. And then this final test is technically for negative numbers, because even though negative numbers will act, they're still, even if this was negative 50, it would still be an even number. But in this particular function, for whatever reason, it was passing false every time I put it through. So I had to sort of I had to change the symbol on it. So I had to, again, go back through and do just thinking about old school math, about canceling out the negative in order to make it a positive, in order to get it to pass what I needed it to pass. And then this last else is just sort of like a catch-all in case like something odd gets through. And then this last return is my saying, if I go through and let's say the number is 9, well, it's going to keep going through this first one and it's going to return, okay, 7. All right, 7 is still greater than 2. Okay, we're going to go back again. It's 5. We're going to keep going back through until we get down to either a 2 or a 1, basically, to tell me whether or not the number is true or false. And then it will return the ultimate true or false. And so that's recursion. I hope that was I hope that was clear. Oh my goodness. Yes, this is as crazy as it looks. And then here. Okay. Can you see the slide that says FYI?
Perfectly.
Great. And then these were just some other call outs that stuck out to me in this chapter. I feel like the idea of explaining what a function is and how to craft a function was the whole point of chapter 3. And then also how to take those functions and basically like stack them inside of each other and make sure that they're talking to each other inside and, you know, creating essentially a larger program that would allow you to make what's the basis of an app or the brain of an app, or, you know, help you think through your logic and different things. So that was the crux of what I got out of this chapter. But some other things that I thought were really important for us to make note of were the fact that functions will either produce a value or they'll produce a side effect, which essentially means that they will just tell you something. So if you write a function that takes in an argument, let's say that the argument is a string, and you pass in, you know, the name Mary, and then inside you do a console log, which a console log is a pure function, or excuse me, is a side effect function, and you say console log and you call the argument string, it's only going to output Mary, and it didn't have to do anything. That is just the side effect of how console log works. Whereas with a pure JavaScript function, you will inherently get a value output as a result of the function having to work. So if you do a function that is called multiply and you have argument A and argument B, if you say return argument A times argument B, then you're only going to get the output value of what A times B is. As I noted before, scope can be both global and local. Anything that is declared outside of your function is going to be considered a global scope as a part of the global scope. And anything that is declared within your function block is going to be considered a part of the local scope, and it is not going to be accessible outside of that function. So if in my even recursion, had I created a new function or a new variable, that variable would only be accessible within the inner function. It would not be able to be accessible outside of that function in the larger wrapping function called isEven. It would not be able to be seen. And there is some weirdness where if you're using let, it can't be seen, but variable has some permeability both backwards and forwards as far as global and local are concerned, but it's not being used anymore with ES6 because constant and let are a little bit more clear and a little bit more strict about global and local scope. And then also the idea of separating your functions allows your code to be dry, which means that you're not repeating yourself over and again. And it helps you organize your logic with how you were thinking about approaching a problem and how things are stacked around. The good thing with JavaScript is that you can have things in different order, even though the order may not be the way that the actual app works. As long as you have all of the pieces together, it will still run so long as you link them together appropriately. And that is it. So do we have any questions or?
I thought that was it was a really good summary of the overall chapter. It's funny because a lot of the things that you just spoke about were things that we talked about in class last night. So I attend a local boot camp at the University of Pennsylvania, and I'm in right over my first month, and you know the word inception was thrown about quite a bit last night, whereas in this scenario we were passing, if you're talking about, there's a method call set interval, clear interval, set timeout, clear timeout, and it has a lot to do with timing activities in the browser if you were creating a timer or a countdown clock or something like that. So to wrap your head around it, you're basically passing a function to a function. So you're not calling the function, i.e. there is no parentheses in the argument section, but it knows that once after the parentheses, you're going to have a time in milliseconds. You're setting that function up to say, I'm a function. I have a function inside me, and I'm going to run it in about 3,000 milliseconds or something. So, and then that was the best example. But then there were other examples of passing functions and then having passing a function in a function, or just having a function inside a function, and then inside that function it calls another function. So your example was spot on, because you have to understand that this is how powerful JavaScript is, because sometimes that's where the logic takes you. It takes you in a way where I need this to be able to do this. So it's not linear that we would see like this function and this function, but it's like I need this function, so I have to go back up here and bring that. So this was very helpful to hear another explanation of recursion, because in those small instances, yes, I was able to get it and it made perfect sense. But I know in the bigger scope, it can be confusing, and you can lose your way, because things are so compact. In the same breath where they say keep all of your functions separate, so your application's modular and this, that, and the other, and then I'm going to have some functions inside of me, and then I'm going to call more functions. So that is actually the opposite of what you would think when you're hearing I'm keeping this modular. Well, it's still modular in that this function does something very specific, but it is dependent on something else. So that's the module, that is modular. But when you think about it, it's like, wow, that's really, it was actually the opposite for how I thought about it. But writing this program I'm dealing with right now, Hangman, again, it's not as complex, but things, it's very modular, but some things have to be inside of other things, and they're getting passed about. So this was actually very helpful for me, my own personal tutoring lesson, which I really appreciate.
Yeah, no, I'm glad that it was really helpful. I think in the past, with things that I have worked on specifically in regard to recursion, I think the issue that makes me most uncomfortable with it is trying to figure out the entry point of where the function should be, right? So like, how do I figure out, like, oh, I know this has to be a recursion. Like, I'm working on a Cold Wars challenge right now, and I know that it has to be a recursion, but the issue that I'm having is figuring out where to put that inner function so that it cycles through everything and gives me the thing that I need, and that it gives it to me effectively enough that I can then bubble it up to the outer function and for it to push out the overall sort of value that I need to return. I've been working on this thing for 4 days, and it is driving me insane. I have also managed to get some other folks in our group to be driven insane by this problem as well. So the crazy is spreading, and I'm happy about that. But at the same time, like, I am learning a lot, as this being sort of like the first time that I really understood recursion, right? Like I feel like perhaps in the past when I was learning it, it was going too fast, and I was just like, yeah, no, I get it. But now I think taking this step by step, like slowing it down, I really do understand what's happening, and I understand that now it needs to be used. And now my only issue is like how to implement it. It's not a question of if or why. It's a question of, okay, now where and how do I implement it?
Agreed.
Yeah.
Cool. What about you, Nayana? Any comments or concerns or aha moments that you had in chapter 3?
I would like to first start off by saying, Charmel, you did an excellent job.
Didn't she?
Yes, not only delivering it, but also presenting it. I was loving the color code. I thought you did a great job.
Thank you.
In terms of recursion from last week to this week, I think that it was a treat to be able to get it a second time, because I feel like you explained it in a way a little more comprehensible than a book did. In terms of, I still feel it's complicated. I'm gonna be honest with you. I'm waiting for my aha moment, because I don't feel like I'm at that level yet. I feel like you all have been exposed to this in ways that I have yet to be. So I'm just looking forward and hoping that when I do my calculator or a timer, that I'll be able to see that. And then I think my question for all of you is, when you're receiving these assignments, are you having to create the logic for yourselves? And basically, recursion, the way we did it, is helping you to apply it to the way you're going to solve it. How are you attacking your problems?
So the way that I attack my problems are by giving myself small wins first, right? So with the book problem that specifically is even, specifically with that problem, when I looked at that, it told us that we needed to ensure that we needed to check for something that would be if something was divisible by 1, and also if something was divisible by 0. So those were the first two that were straightforward that I could code against, right? Like, and this was before I even created the inner function. So before I could even think about isolating the last integer, and before I could think about doing any of those other things, I was like, I need to make sure that the number that's passed in, if it's divisible, you know, if it comes up with 1 or it ends with 0, I can get true or false off the top. And if I can make those wins, then that's what I'll do. Those were the first things that I made sure that I could code against and answer those questions. And then I built from there, right? My next question was, or my next idea and thing that I realized was, oh, I'm working too hard trying to figure out the entire number of 50, right? And that's what made me think about, oh, no, I need to go back to old school 3rd grade math rules, and I need to figure out now how to isolate the last number, and that be the argument that I'm passing and comparing and working through. So whenever I go through any of these problems, all of the problems so far, I think about it from the idea of being a beginner. Like, a beginner doesn't know about all of these super high functioning methods that are a part of JavaScript. They don't understand, we wouldn't understand sort of all of those things that are available. So I work from the base of knowledge that I have. Like, is this thing possible for me to do? Yes, great, okay. How do I execute this one thing, this one chunk of code? Like, how do I make it say true if it ends in 0? And then, like, I build from there. It's probably not the best looking code, and it's probably not the most dry, and it's probably not the most easy to read, because it is like, you saw that recursion, like it's huge, it's super long, but it works. And I can walk through it and I can explain it and I can read it. And if someone's like a beginner, it's easy for me to walk them through that process to help them understand how, to get what they need out of it. So that's how I approach, that's how I've been approaching all of our problems in the book, is by starting with the hints that they give us in the book, by saying that, because they always seem to give us one thing that's like, you have to execute this one thing, and it is always the most straightforward thing, and I always start from there and work my way out from there. So
well, cool. I think that was a really good explanation of the chapter in general, especially recursion, because that is a very tricky, I mean, people stayed after class last night trying to get that, so I understand it. Being able to, the minute you, the programmer, can see it and, figure out how to use it successfully, I think that's when the light bulb tends to open up. So for, like you said, like you can kind of hear it and it's like, oh yeah, I understand it, but it really doesn't hit home until you're in that position where you're coding something. And that's why I think it's a really good idea that, everyone gets an opportunity to run these book club meetings, because you're really going to put yourself in this position that I have to understand this. Even if it's just a part of it, you'll take that part and you'll give it the attention and the time that it needs to try to digest it. And I think so far that's what we've all done. It's like, wow, you really get this because you're reading it, and it's not a passive read. It is not a passive read. It is very active. It is hands on it and wrapping your head around it and putting it into code and understanding it and flushing it out. So I like the fact that you were able to do this week, because it was helpful for me. And going forward, I think everyone is going to get that opportunity to dig in and just get something that, just by us just reading it, again, it's very passive. I'm telling you, when you have to be the one driving this bus, you're going to get it. Because you have to explain it. So that is the mastery of what we're doing here. So if Nayana, do you have any more comments? Because this was pretty spot on for chapter 3.
Yeah, Charmel did the whole chapter in a few slides.
I know!
Freaking a mess.
I love that.
Me stuttering and trying to figure it out. I was like, Charmel, you said it all.
You said it all.
I mean, I do what I can.
And she's modest, so there's that.
I mean, I'm just out here.
Yes, I love it. I love it.
If you guys have any questions about, like, this chapter, I don't know, like, I must have been inspired by being able to get through the recursion problem.
You should be.
I did all of the other problems too. I am curious to see how everyone else solved them, because my approach to stuff is always like trying to figure out the easiest way to answer something, right? Like,
so this was, I'm scrolling through the chapter myself and seeing the bean counter. Oh yeah,
I did that one.
I did that one too. What else was it? I didn't do the recursion, and we talked about this last week, and I was like, yeah, no, but I did the bean counter. Like, I kind of like was, at least I did something. I read it and I was like, nope, I'm not even gonna. I have other things. I have homework. I gotta move on.
Sure. Yeah.
I had to move on. So, I don't have an example, but I promise before long I will have something to show and contribute. I need to find my bean counter and share that, because that was one that I was able to do, and I had to think about it, and it came into fruition. So yes, I will definitely share that. And sure. So we're next week. Again, I'm going to wrap this up, because this was a very successful chapter 3 of Eloquent JavaScript. We are reading the 3rd edition, although this is the 2nd edition. The 3rd edition hasn't come out in print yet, so you can go to eloquentjavascript.net and you can read the third edition there. It is free. It is available. Send the PDF to your Kindle app, you know, read it on the bus, get it in wherever you can. Next week, it'll be Chapter 4, Data Structures, Objects, and Arrays. This is the bread and butter of JavaScript. So we are going into bread and butter next week. So we need a little bit more time to digest this chapter, but we will be back. There'll be a few more book club attendees in attendance, and we'll have a really lively conversation. So I want to thank you. I will definitely leave the link to the Eloquent JavaScript book so you can grab it and read along. And if you have any comments or questions, post them below. And we will see you next week. So you want to say bye, Charmel?
Yeah, bye, Charmel.
And Nayana, you want to say bye?
Bye, everyone.
Thank
you for joining.
Thank you so much for joining us. We'll see you next week.